Hi, today we're going to learn about geometric proofs. A two-column proof is named because it involves two columns, one for the statements of the proof and one for the reasons of the proof. Every proof that you will be given will involve a given statement, which provides information, a picture, and a proof statement, which is what you are asked to prove based off of the given statement. You will be responsible for filling in the statements and the reasons. What can you use as reasons? You can use the given information and any postulates, theorems, properties, definitions, or corollaries that we've already covered. For our first example, we're going to start out, we're given that we have angle AOD as shown. Typically, you will have more information and the given will start out your problem. But for this proof, we're going to start by taking apart angle AOD and saying that it's equal to the measure of angle AOC plus angle 3. This would be the angle addition postulate, which allows you to add two smaller angles to equal a larger angle. In statement number 2, we're going to take apart angle AOC and break that down into the measure of angle 1 plus the measure of angle 2, which is also the angle addition postulate. And finally, we will reach statement number 3, which will be our proof statement. That's always the last statement of the proof. And what we've done to get this proof statement is we have substituted angle 1 and angle 2 in place of angle AOC. We're replacing this quantity with a quantity that it is equal to. And again, that would be the substitution property. For example 2, we're given that segment FL is equal to segment AT, that is marked by congruent marks in the diagram. We're going to prove that segment FA is equal to segment LT. So we're going to start with our given for number 1, which you may have noticed is segments FA and LT both contain segment LA. So we can use the reflexive property to say that that segment is equal to itself. And then if we add both of the quantities on this side of the equal sign and both of the quantities on this side, which is the addition property, we would get that FL plus LA is equal to AT plus LA. You may recognize that FL plus LA, if you add those two smaller segments together, you get larger segment FA. And then if you add LA and AT together, you would get the segment LT. That's segment addition. And finally, we can use substitution to replace FL plus LA with FA and AT plus LA with LT to get our proof statement that segment FA is equal to segment LT. And for our last example, we are given that the measure of angle 4 plus the measure of angle 6 is equal to 180. So we'll start with that as our first statement and reason. For our statement number 2, you can see from the diagram that the measure of angle 4 and the measure of angle 5, they make a straight angle. So that's 180 degrees. That would be your angle addition postulate. For statement number 3, we're taking this 180 and we're replacing it with the equal quantity angle 4 plus angle 6. So that is substitution. In statement number 3, both of these sides of the equation have angle 4, and since angle 4 is equal to itself by the reflexive property, we can remove angle 4 from both sides of the equation and end up with angle 5 is equal to angle 6. And since we remove something from both sides, we are subtracting, so that would be the subtraction property.